Hi everyone. So this is the Buddipole Powermini USB, a unique 12-volt DC pocket-sized power control system particularly suited for portable operations for amateur ham radio. This highly integrated device incorporates the functions of a solar charge controller, battery management system, power monitoring device, and power distribution in a small, robust, weather-resistant package. Now that's the description of in the manual, and it can do 150 watts of from the solar panel at 11 amps, and it can also discharge over here on the load up to 35 amps. Which is pretty incredible. All right, so what does that all mean? Well, it means that, first of all, the charge controller portion, whatever comes out of the solar panel, it manages the power and it puts it into the battery safely, charges the battery safely. It will make sure that it's charged appropriately, depending on what type of battery chemistry you have. And that's one of the great things about the Buddipole, that it can do lithium, iron phosphate, lead acid, lithium polymer, and 3-cell lithium iron phosphate batteries as well. So you're not stuck with one particular battery chemistry. So that's an advantage. One thing that most of these solar controllers have is that you can put a load, and it might have a USB. But this one in particular has these Anderson power poles, which is invaluable in the amateur ham community. So let's talk about some of the features and some of the things that you can do with it. So first of all, when you plug it in over here, you have the battery and the solar. When you plug it into the battery on this side, you have a blue and black. Blue probably be for battery. The Anderson power poles, usually the colors are red and black, but black and black, and then blue and red, and it powers the device. Now, here, with this particular battery, this is 12 volt, 12 amp hour. I use this in the field so I can power my IC73 and also power other devices, which I had all these other connections. But with the Buddipole, I can definitely manage it a little bit better, specifically when you have a solar panel too. So this is the connection for the solar panel. I put an Anderson power pole for the line that goes to the solar panel, and over here on this side, which is pretty neat, it has a yellow, probably for sun, and then black, and it does say solar on there. So black to black, red and yellow, and then we connect it. And right now the solar panel is indoors, so it's not really doing anything to charge this, but you can see that there's some voltage there. Okay, so here we have some interesting analytics. We have the voltage of the battery, how much amps are coming out. Right now 0 because there's nothing connected to the Buddipole, and how much charge has come out of the battery, which is 0 because we haven't done anything to it. And then here on this side, this vertical bar kind of tells you where the battery is, how it's, kind of like gives you an idea where the charge is. It goes from 10 to 16 volts. So it's kind of like a visual representation. The little star means it's going to beep when it goes, below a certain amount of voltage. I don't know if it beeps if it goes above a certain voltage. And then this other vertical bar that you have here, That's going to tell you the load, how much amps are coming out of the system. Now this battery can only handle 20 amps max peak. Of course, there's other batteries that can handle more. The cool thing about the Buddipole, it can handle up to 35. Let me make sure here. I'm pretty sure it's 35. Yes, 35 amp continuous maximum load current. And looking at the documentation, Powermini will automatically disconnect the outputs if the maximum load current exceeds 35 amps. Okay, so that's the battery side. The solar side gives you the voltage, how much voltage there is. Right now, the solar panels is in the room, so it's not collecting any sun. This is how many amps that's currently being pumped, which is 0. That makes sense. And then the amps, how much amps or how much charge has been pumped out of the cells. Okay, then on this side we have also Anderson power poles. That's the great thing about this device. Most amateur ham radio operators are now considering Anderson power poles as a standard in terms of connecting to their radios and other equipment, which gives you the proper polarity. And they're very solid type of solution for managing power to your devices. So I'm going to connect, this is the IC73. I'm going to connect it here perfectly. And just by connecting it, you see it's drawing just a little bit of power, 0.03. I haven't even turned it on yet. So what I'm going to do, I'm going to turn on the IC73. All of a sudden, it's taking up some power. You can see it's 0.91 amps, which is perfectly safe. That's just the radio being turned on. It's taking about 1 amp. This battery is 12 amp hours. So if I didn't do anything, I expect this battery to run this radio for 12 hours. And you can listen easily to the radio. Now, what else can I do? Well, let's say I wanted to charge my phone. That's easy. You get a USB connection, hook it up over here, then take your phone, plug it in, and it's being charged. So now it's added about 0.45 amps, a half of amp. So now you have your IC73 and your phone connected, and it's drawing about 1.2 amps. The solar is not connected to this. There's no sun right now in the room, so the solar panel is not giving any charge. But if the sun was out and this panel was out there, then it would probably be giving some power to it. The solar panel that I have is the PowerFilm 14 watt, which gives 0.9 amps when it's full sun. So it wouldn't be able to cover all of it, but it would be able to cover some of the loss of the battery. Okay, so I got one load here to the IC73. I got a phone being charged. What else can I do? Well, I have another connection. Another. I can put another load, like maybe the tuner, which requires 12 volts, or I can connect something like a Raspberry Pi. Now this one is a Raspberry Pi 4, which can draw almost 3 amps. The USB connection over here, specification says 1.5 volts. It's possible that you can run this through the USB, most likely, but if it's going to draw more power, it might not be able to fully run a Raspberry Pi 4. So what you can do is you can get one of these USB Buddy from PowerRec. This will take 10 or 32 volts in and then convert it into 5 volts, 3 amps out through a USB. So let's connect this here. And it doesn't change anything because there's no load to it, but it's ready. It's ready for you connecting something. And let's say you connect your Raspberry Pi. So let's do that. Okay. All right, let's try it. There it is. This is USB-C, by the way. And you can see the little lights blinking. And it doesn't seem to be taking a lot of power. Probably a tenth of an amp, maybe a little bit more. A fifth of an amp, maybe. Right? It's not, of course, if you connect other devices here, it's going to draw even more. But I like using this because this might draw a lot of power. Just talking for the few minutes that we've been showing the Buddipole, you can see that the Buddipole has demonstrated that it's already marking 0.1 amps out of the battery. 1/10 of an amp. The amps, in an hour, right? So far, if we left this, it seems like in the time that we've had this set up, it's only drawn 0.1 amps. Now, it just turned off, meaning we've only it means that this setup has been turned on for about 5 minutes. So now we're going to press this and then it turns this on. Solar, of course, there's nothing there. All right, so this indicator here will tell us the load coming out, and it doesn't seem like it's very big. So what I'm going to do is I'm going to click on the RF power on my IC73, and I'm going to lower it down to 10%. We don't need to draw too much from the battery right now. And what I want to see is when I transmit, and I'm looking at the band right now, band is pretty dead at where it is right now, but when I transmit, you'll see the this bar change in height, indicating the amount of power that can be pulled out of the battery. This battery, it says right here, 12 amp max continuous discharge. So I got a lot of amps that I can pull out, and 20 amp max peak. So here I'm going to click on the power or transmit. You'll see a change in the amps here, and then you'll see a bar that goes up. Here we go. See that? It went almost to 4.39, and this bar is right there. The bar goes from practically 0 to 35 amps. So the setup can easily handle the situation. Sure, you can increase your RF power, let's say to 50%. And we'll click on this, and you can see it only gives you 4 amps. And in a peak, probably a little higher than 4.5. If I go 100%, well, not 100%, let's do 90%. Only 4.3 amps. Which is not bad. All this time I'm looking at the band. Bands are completely dead. Okay, let's stop the demonstration there. Lower down the RF here. And it's still continuing to run. Fascinating that this little device, which is not warm at all, this little device here is charging my, well, the battery, of course, is charging my phone. It's running my Raspberry Pi 4 through USB-C using a USB buddy connected to a Anderson power pole on load 2, and then on load 1 you have the ICOM 7300, which can do 100 watts. Pretty amazing. All right. Some of the specifications on the battery: it can be up to 24 volt DC. That's the max. The min input voltage is 9. Maximum solar input voltage is 24. Maximum load current, right, is continuous, is 35. Maximum solar charge current, right here, right, is 11 amps. 2 12 volt DC power pole Anderson, which, by the way, they're rated at 45 amps. So the connections, the metal that's in there. USB A type connector, we talked about that. 5 volts for the USB, 1.5 amps, we talked about that too. And other settings that can be adjusted. We'll talk about that a little bit right now. So if we click on the I guess a select button here, it gives you a system report, the power uptime. It seems like it's been on for a third of an hour. Solar power. Well, the solar panel is connected, but there's no power at all. And the peak, none. And the battery use is 0.25 so far. This value here, battery use, I believe is the one that goes negative when you have the solar panel on. Let me see. Battery use, net battery charge used, the difference between charge used and charge replaced by the solar panel. A negative value shows more charge has been put into the battery than taken out. Okay. All right, so of course it's not negative. There's no sun on the solar panels. All right, let's press this again. Here we have the type of battery, right? Lithium iron phosphate, lead acid, lithium polymer, and 3-cell lithium iron phosphate. And what you can do is you can press and hold on select, and then you can change the values of the type of battery you're using. These are default values here, but you can always change them. Oops. We can click on select, and then you can change these values here. 14.4. I'm going to leave them in the default setting that they are. These are appropriate for my battery. And if you click one more time, it disappears. So the max charge at 14.4, that's as far as I want the sun to charge my battery. And then low voltage, it will beep, or actually, yeah, I think it will beep, or do, depending on the settings on how it's configured, it will turn it off completely, the battery, in terms of what it's doing in the load. And then apparently 11.5, when the battery gets to 11.5, it restarts and says, okay, let's do this again. Turn the Buddipole on. And then auto off, disabled. So right now, I don't want the Buddipole to turn off when it gets at a certain point. But of course, if it gets down to 10, I believe, 10 volts or 10.5, it will turn it off completely, even though this is disabled. The alarm is on. It'll warn me if the voltage is too low. And then apparently high voltage, it will definitely turn off at 15.5, and high voltage reset at 15. So that, depending on your equipment, I'm just going to leave that the way it is. And then that's it. Those are the settings. All this information is in the manual, and definitely you should read the manual. There's other things probably I need to keep reading, but this is really, really nice. So I really like this the way of distributing the power. I don't have to worry about bringing like a hub, right? Connecting the battery to a hub and then connecting the devices. Usually I'm not using, at the moment, the Raspberry Pi, but if I do, definitely I can use this. I can also see a configuration where I might bring in a amplifier for the IC705 maybe. I can connect that, or even better yet, maybe a tuner, and I can connect it here. A lot of ways of doing that, and I'm pretty sure you can use one of these to connect to a hub, and then you'll have 4 other ports, and then you can connect that. You can probably strain it to the point, because it goes up to 35 amps. Of course, you got to test that, see what other users are doing with the unit. But I'm pretty confident that it will be able to do it. I haven't taken this on the field yet. As a matter of fact, this is kind of like more of an unboxing, a little tutorial that I feel, that it's going to be helpful for other people to understand sort of how this thing works, and some of the values here. I think, again, you should look at the manual, read it, make sure how to configure it for your system so that you'll be absolutely sure that everything is working properly. Because a lot of these things are very sensitive equipment, and you got to make sure things are connected correctly. So if you have a question or a comment, please leave it down below. I appreciate any feedback. If you like this video, please give it a thumbs up, or consider giving it a thumbs up. Please subscribe, and I hope I'll see you out there. This is Frank, KN6 BST 73.